So we're going to spend some time this morning learning how to set up a model to model the radioactive decay by checking different decay constants. So the first thing that I'm going to want to do is use the equation n equals n naught exponential, and I'm going to use minus lambda right here, t. So I know the equation that I'm going to be using this morning. So what I need to do now is initially start off by telling the computer some initial conditions. I'm going to start off with an n0 value of 1 million nuclei. What I want to do is look at the way that this is affected by different decay constants. So I'm going to put in a symbol here for the decay constant lambda. And what I'm going to do then is plot a graph that looks at how the number of undecayed nuclei is affected by the time. So we have this one as n. So under the time, I'm going to try for different quantities of time. I'm going to have increments of 1/10 of a second. No, 1/100 of a second. So we're going to say it's going to be equal to 0, previous value, plus 0.01 seconds. And then I'm going to copy that down quite a long way. Let's go for about 700 increments. Then I need to scroll back up again, and I need to try and put corresponding values in here. Well, the number of undecayed nuclei is equal to the number of nuclei that you start with, and that's not going to change, so I need to put some dollar signs in front of that. And that's going to be multiplied by the exponential function, lots of minus the decay constant. Well, the decay constant is something I'm going to put in a moment, but it's going to go into cell B4. And it's going to be a constant value for the entire duration of each individual experiment. Then I'm going to times that by the time through the experiment. I'm going to close that value, I'm going to press enter, and then what I'm going to do is I'm going to copy that down as well to 700. Now you can see that hasn't changed, and the reason for that is because currently there's a 0 probability of decay. So what we need to do is insert a number here. Now I'm going to do that by putting a slide bar in. And the way that I do that is, first of all, by going to File, to Options, and then under the Customize Ribbon tab, under Main tabs, I'm going to tick the Developer toolbar. I'm going to click OK, and you'll see that the Developer tab immediately becomes obvious at the top of the screen. I click that, and then tell it to insert. I'm going to insert a scroll bar, and I'm going to tell it that my scroll bar is going to go in here. Very pretty. Now I need to tell the scroll bar what values it can take, and I'm going to start at 0. I'm going to have an incremental change of 1. I'm going to go up to 1,000. Sorry, to 1,000. Now, the probability cannot be anything greater than 1. I need to tell it where to put those numbers as well. So if I go back to Properties, I tell it that I'm going to want this value to go in, I'm going to put it into B2, not into B4. And the reason for that is, just as we've said, we can't have probability of greater than 1. So because my maximum probability here is 1,000, whichever value this takes, I need to divide by 1,000 to get a number between 0 and 1. So I'm going to make this equal to B2 divided by 1,000. If I do that, you can see that my probability will now take values between 0 and 1. So I need to plot a graph now of this information. I'm going to highlight the values that I want to plot all the way down to 700. And then I'm going to insert a scatter graph of that data. Beautiful. There's my exponential curve. Let's now just play around with our graph options to make it pretty. Add a title. This is good practice. But the important thing that I want to do now is I want to take that graph and I want to put it at the top of the page. And the nice thing that I can do now is I can change the value of the decay constant and see how that affects